In the vast, uncharted reaches of the cosmos, a solitary human-made object drifts farther from Earth than any other, carrying with it the hopes, dreams, and curiosity of a species yearning to understand its place in the universe. Voyager 1, launched on September 5, 1977, from NASA's Kennedy Space Center, has become humanity's farthest emissary, a testament to our relentless drive to explore the unknown. For nearly 5 decades, this spacecraft has pierced the veil of outer space, sending back data that has reshaped our understanding of the solar system and beyond. Yet, in recent months, something extraordinary has emerged from its distant transmissions, signals that defy explanation, stirring both excitement and unease among scientists. These erratic pulses, unlike anything Voyager 1 has sent before, have ignited a global conversation. Are these the signs of a mechanical failure in an aging probe, or could they hint at something far more profound? Perhaps a message from the stars themselves. As we stand on the cusp of unraveling this enigma, let us journey through the remarkable saga of Voyager 1, its triumphs, its discoveries, and the tantalizing mystery that now captivates the world. The story begins in the late 1970s, an era when humanity's ambition to explore the cosmos was matched only by its ingenuity. On August 20, 1977, Voyager 2 lifted off, followed just weeks later by its twin, Voyager 1. These spacecraft, each weighing roughly 721 kilograms, about the size of a small car, were designed to embark on a grand tour of the outer planets. Their mission was audacious: to capture images and data from Jupiter, Saturn, and beyond, revealing secrets of worlds that had long been mere specks in our telescopes. By December 15, 1977, Voyager 1 had already outpaced its sibling, its trajectory sending it hurtling toward Jupiter at a breathtaking 325 million kilometers per year. This speed, combined with the clever use of gravitational assists, slingshot maneuvers harnessing the pull of massive planets, allowed Voyager 1 to cover vast distances with remarkable efficiency. In 1979, Voyager 1 reached Jupiter, some 265 million kilometers from Earth. Its cameras, among the most advanced of their time, captured the gas giant in unprecedented detail. Over a 100-hour period, the spacecraft produced a time-lapse sequence of 3,750 images, revealing Jupiter's swirling, turbulent atmosphere and its iconic Great Red Spot, a storm larger than Earth itself. These images were more than scientific data. They were a window into a chaotic, alien world. Voyager 1 also uncovered a faint ring encircling Jupiter, a discovery that stunned astronomers who had assumed such features were unique to Saturn. Even more astonishing was the detection of 2 previously unknown moons, adding to the complex tapestry of Jupiter's system. These findings reshaped our understanding of the gas giant, revealing it as a dynamic, ever-changing world. As Voyager 1 continued its journey, it approached Saturn in 1980, navigating a delicate path to avoid a collision with Titan, the planet's largest moon. This maneuver required precise calculations, as even a slight misstep could have ended the mission. The spacecraft's instruments recorded detailed images of Saturn's rings, unveiling their intricate structure and composition. Voyager 1 also discovered 4 new moons, Mimas, Enceladus, Tessis, and Rhea, each with its own unique characteristics. Enceladus, in particular, would later become a focal point of scientific interest due to its icy surface and potential subsurface ocean. These discoveries marked a turning point, transforming Saturn from a distant planet into a complex system worthy of further exploration. With its planetary flybys complete, Voyager 1 set its sights on a new frontier, interstellar space. On February 14, 1990, from a distance of nearly 6 billion kilometers from the Sun, the spacecraft turned its cameras back toward home, capturing the now iconic family portrait, a series of 60 images showcasing the inner planets of our solar system. Among these was the pale blue dot, an image of Earth as a tiny speck against the vastness of space. This photograph, more than any other, underscored the fragility and unity of our world, inspiring generations to reflect on our place in the cosmos. The image archive, now containing hundreds of thousands of photos, remains one of Voyager 1's most enduring legacies. While Voyager 1 ventured into the unknown, its twin, Voyager 2, carved its own path through the solar system. In 1986, it became the first and only spacecraft to visit Uranus, revealing a planet with a peculiar, tilted magnetic field that defied existing theories. 3 years later, Voyager 2 reached Neptune, where it recorded wind speeds exceeding 2,100 kilometers per hour, the fastest ever documented in our solar system. Its observations of Triton, Neptune's largest moon, were equally remarkable, revealing surface temperatures of -391 degrees Fahrenheit, -235 degrees Celsius, and cryovolcanic activity that ejected nitrogen gas and frozen material up to 5 kilometers high. These findings painted a picture of a solar system far more dynamic and diverse than previously imagined. The Voyager missions were not just about capturing images. They were equipped with an array of scientific instruments designed to probe the mysteries of space. Magnetometers measured the magnetic fields of the outer planets, revealing how these forces interact with their moons and rings. Plasma wave detectors analyzed the solar wind, providing insights into its effects on planetary atmospheres. Perhaps most significantly, the spacecraft mapped the heliosphere, the vast bubble of solar particles and radiation that envelops our solar system. As Voyager 1 approached the heliosphere's boundary, known as the termination shock, it detected a dramatic shift. The solar wind slowed and compressed, giving way to the interstellar medium. Beyond this lies the heliosheath, a turbulent region where solar and interstellar forces collide. These observations have offered critical clues about the invisible shield that protects Earth from cosmic radiation. On August 25, 2012, Voyager 1 achieved a historic milestone. It became the first human-made object to enter interstellar space. This transition marked a new chapter in its mission, as it began to study the composition and behavior of interstellar matter, the sparse gas and dust that fills the void between stars. The spacecraft's instruments detected cosmic rays, high-energy particles traveling near the speed of light, offering glimpses into the distant processes of star formation and galactic activity. Voyager 1 also revealed the structure of interstellar magnetic fields, shedding light on their role in shaping the galaxy. These discoveries have challenged long-held assumptions, revealing a cosmos far more complex than scientists once believed. Yet, it is the recent transmissions from Voyager 1 that have captured the world's attention. In early 2025, NASA engineers noticed irregularities in the spacecraft's data streams, signals that appeared garbled, inconsistent, or entirely unexpected. Unlike the clear, structured telemetry of the past, these transmissions contained anomalies that defied immediate explanation. Some speculated that the spacecraft's aging systems, now nearly 50 years old, were beginning to fail. Voyager 1 relies on a dwindling supply of power from its radioisotope thermoelectric generators, which lose efficiency over time. To conserve energy, NASA has gradually powered down non-essential systems, a strategy that has extended the mission's life but cannot prevent the inevitable. Could these signals be the result of a malfunctioning antenna, a corrupted computer, or failing sensor? Others, however, have dared to consider a more extraordinary possibility, that these signals could be evidence of contact with an unknown intelligence. The idea, while speculative, is not without precedent. Voyager 1 carries a golden record, a message to any extraterrestrial life it might encounter. Etched with greetings in 55 languages, music from diverse cultures, and natural sounds like thunderstorms and whale calls, the record is humanity's handshake to the stars. Could an advanced civilization have intercepted Voyager 1, decoded its message, and responded in a way we do not yet understand? The scientific community remains cautious, emphasizing the need for rigorous analysis, but the possibility has sparked a wave of excitement and debate. To understand the significance of these signals, we must consider the challenges of communicating across interstellar distances. Voyager 1 is now over 24 billion kilometers from Earth, so far that its signals take more than 22 hours to reach us. These transmissions, sent via a 23-watt transmitter, equivalent to a refrigerator light bulb, are faint whispers against the cosmic background noise. NASA's Deep Space Network, a global array of radio telescopes, strains to capture these signals, which are then decoded and analyzed by teams of engineers and scientists. The recent anomalies have required new approaches, including the use of advanced algorithms to filter noise and identify patterns. So far, the results remain inconclusive, but each new transmission brings fresh hope of unraveling the mystery. The Voyager missions have always been about pushing boundaries, both technological and intellectual. When Voyager 1 was launched, it carried state-of-the-art technology, cameras capable of capturing images in multiple wavelengths, spectrometers to analyze planetary atmospheres, and particle detectors to measure cosmic radiation. These instruments, though now outdated by modern standards, were revolutionary at the time. The spacecraft's design, with its slow rotation to stabilize images and its robust communication systems, allowed it to survive the harsh radiation of Jupiter's magnetosphere and the extreme cold of interstellar space. The success of these systems, combined with NASA's innovative energy management, has kept Voyager 1 operational far beyond its original 5-year mission. The discoveries made by Voyager 1 and 2 have had a profound impact on science and culture. The revelation of active volcanoes on Io, Jupiter's moon, was a game-changer. Images showed eruptions spewing material hundreds of kilometers into space, with one event estimated to be 1,000 times more powerful than the 1980 eruption of Mount St. Helens. These findings upended the notion that moons were geologically inert, sparking new research into the possibility of subsurface oceans and habitable environments. Similarly, Voyager 2's observations of Uranus and Neptune revealed worlds with unexpected complexity, from Uranus's misaligned magnetic field to Neptune's dynamic atmosphere. These insights have fueled decades of study and inspired missions like New Horizons, which explored Pluto in 2015. Beyond their scientific contributions, the Voyager missions have captured the public's imagination. The pale blue dot image, showing Earth as a fragile speck in the cosmic void, has become a cultural touchstone, reminding us of our shared humanity and the need to protect our planet. The Golden Record, with its eclectic mix of sounds and images, embodies our hope for connection with other intelligent beings. From Beethoven's symphonies to the laughter of children, the record is a snapshot of who we are, or who we were in 1977. It is a gesture of optimism, a belief that somewhere, someone might hear our story. As Voyager 1 continues its journey, now over 15 billion miles from home, it faces an uncertain future. Its power supply is expected to last until around 2030, when its instruments will likely fall silent. Yet, even in its final years, the spacecraft remains a beacon of human achievement. Its data on interstellar matter, cosmic rays, and magnetic fields continues to inform our understanding of the galaxy. The anomalies in its recent signals, whether due to technical failure or something more extraordinary, have reignited interest in the mission. Scientists are combing through decades of data, comparing current transmissions with past patterns, in hopes of decoding the mystery. The possibility of extraterrestrial contact, while remote, cannot be entirely dismissed. The universe is vast, with billions of stars and countless planets. The Fermi paradox, the question of why we have not yet detected intelligent life, looms large, but Voyager 1's golden record was designed with the possibility of discovery in mind. If an alien civilization were to encounter the spacecraft, they would find a message of peace and curiosity, encoded in a form meant to endure for 1 billion years. The recent signals, though likely the result of technical issues, have prompted scientists to revisit the protocols for identifying non-human intelligence, a field known as SETI, Search for Extraterrestrial Intelligence. For now, the focus remains on understanding the data. NASA has deployed additional resources, including machine learning models to analyze the signals and simulations to test possible causes. The spacecraft's distance and age present unique challenges. Commands sent from Earth take nearly 2 days for a round-trip response, and the hardware, built in the 1970s, is unlike anything in use today. Engineers have had to rely on archived manuals and the expertise of retired team members to troubleshoot the issue. The process is slow, but each new piece of data brings us closer to an answer. The Voyager missions have always been a testament to human ingenuity and perseverance. From their launch in 1977 to their entry into interstellar space, they have defied expectations, delivering discoveries that have reshaped our view of the universe. The gravitational assist that propelled them across the solar system, the images that revealed the beauty and complexity of distant worlds, and the data that continues to stream back from the edge of the heliosphere, all are monuments to what we can achieve when we dare to explore. The current mystery surrounding Voyager 1 signals is a reminder that the universe is full of surprises, waiting to be uncovered. As we ponder the meaning of these transmissions, we are reminded of the broader context of space exploration. The Voyager missions were built on the foundation of earlier efforts, like Pioneer 10 and 11, which paved the way for deep space exploration. On February 17, 1998, Voyager 1 surpassed Pioneer 10 to become the farthest human-made object from Earth, a title it still holds. Its journey has inspired new missions, from the Juno probe orbiting Jupiter to the Europa Clipper, set to explore the icy moon of Enceladus. The technologies developed for Voyager, such as advanced imaging and energy-efficient systems, have found applications in countless other fields, from medical imaging to satellite communications. The cultural impact of Voyager cannot be overstated. Its images of Jupiter's storms, Saturn's rings, and the pale blue dot have become part of our collective consciousness, shaping how we see ourselves and our world. The Golden Record, with its message of unity, has inspired artists, writers, and dreamers to imagine a future where humanity reaches out to the stars. The possibility that Voyager 1's signals could be something more than a technical glitch taps into our deepest hopes and fears about what lies beyond our world. As we await further analysis of Voyager 1's transmissions, the mission continues to teach us about resilience and curiosity. The spacecraft, now a relic of a bygone era, operates in conditions no one could have fully anticipated. Its instruments, though limited by today's standards, are still providing data that challenges our understanding of the cosmos. The heliosphere, once thought to be a simple boundary, has revealed itself to be a complex, dynamic region. The interstellar medium, far from empty, is a rich tapestry of particles and forces that we are only beginning to understand. The mystery of Voyager 1 signals is a call to action for the scientific community and the public alike. It reminds us that exploration is not just about finding answers, but about asking new questions. Whether the anomalies are due to a failing system or something more profound, they have reignited our passion for discovery. The Voyager missions, now in their 5th decade, continue to push the boundaries of what is possible, challenging us to look beyond our world and imagine what might be waiting in the infinite expanse of space. In the coming months, NASA will continue to analyze the data, consulting with experts across disciplines to unravel the mystery. The process will require patience, ingenuity, and a willingness to embrace the unknown. For now, Voyager 1 drifts on, a lone sentinel in the vastness of the cosmos, carrying humanity's message to the stars. Its journey is far from over, and its legacy will endure long after its final transmission fades into silence. The story of Voyager is the story of us, our curiosity, our courage, and our unrelenting desire to explore the unknown. As we listen to the whispers from the edge of the universe, we are reminded that the greatest discoveries often begin with a single, unexplained signal.